In this video, we'll take a closer look at balancing equations. First, let's review the basic setup for a chemical equation, where the reactants are on the left-hand side of the arrow and the products are on the right-hand side of the arrow. The reactants are the substances that come together, collide, and then after they form new substances, we call them products. Here are the steps to balance a chemical equation. First, write out the unbalanced equation. Then, count the number of atoms of each element on each side of the equation. To balance the equation, to make the number of atoms equal on both sides of the equation, you can add coefficients. If you add a coefficient in front of a molecule or a compound, you must multiply that coefficient times the subscripts in order to determine the number of atoms present. For example, placing a coefficient of 2 in front of the formula CaCl2 would mean that there would be 2 calciums and 4 chlorides. Then, once you think the equation is balanced, check to see if all the coefficients can be reduced. If they can, reduce the coefficients to the lowest possible ratio. Finally, double-check that the number of atoms is the same on both sides of the equation. That's when you know it's balanced. Here are some helpful tips to use when you balance equations. Balance one element at a time. Update the atom count anytime a coefficient is changed. If an element appears more than once per side, balance that element last. And balance polyatomic ions as single units. For example, treat the polyatomic ion sulfate as one sulfate, instead of trying to balance it as one sulfur and 4 oxygens. Here's an example of an equation that needs to be balanced. Aluminum and copper 2 chloride react to form copper and aluminum chloride. The reason there are 2 chlorides in the formula for copper 2 chloride is the copper ion has a charge of 2+. And since chloride's charge is 1 negative, we will need 2 chlorides to balance the charges and make this a stable ionic compound. Similarly, the reason there are 3 chlorides in the formula for aluminum chloride is the aluminum ion has a charge of 3+, so there will need to be 3 chlorides, each with a charge of 1 negative, in the formula to balance the charges and make this a stable ionic compound. Something to keep in mind is that although this particular reaction is a single replacement, we could use these steps to balance an equation for any of the reaction types we have previously discussed. Going back to our problem, when you look at the number of atoms on both sides of the equation, you see that there are 3 chlorides on the product side and 2 chlorides on the reactant side. That's not balanced. The lowest common multiple of 3 and 2 is 6. So if you put a 3 in front of the copper 2 chloride and a 2 in front of the aluminum chloride, you have 6 chlorides on both sides of the equation, so the chlorides would be balanced. Now you can balance the aluminum by putting a 2 in front of the aluminum on the reactant side, and you can balance the copper by putting a 3 in front of the copper on the product side. Remember to go back and double-check to make sure you have the same number of each element present on both sides of the equation. There are 2 aluminums on the reactant side and 2 aluminums on the product side. There are 3 coppers on the reactant side and 3 coppers on the product side. And we have 6 chlorides on the reactant side and 6 chlorides on the product side. This equation has been balanced. Here's another equation that needs to be balanced. In this reaction, there are polyatomics that appear on both sides of the equation, so let's review the helpful hint we discussed earlier for dealing with these types of equations. You have 2 nitrates on the product side and 1 nitrate on the reactant side. Balance those nitrates as complete polyatomic ions. Don't try to break them up into individual nitrogen and oxygen atoms. With 2 nitrates on the product side, you need to put a 2 in front of the silver nitrate on the reactant side in order to get 2 nitrates on the reactant side, and that will balance the nitrates. Now there are 2 silver on the reactant side, so you will need to put a 2 in front of the silver chloride on the product side, and that will give you 2 silvers there as well. That also happens to balance the chlorides, because there are 2 chlorides present in calcium chloride on the reactant side, and by placing a 2 in front of the silver chloride, that gives us 2 chlorides on the product side as well, which will balance the chlorides in the reaction. Let's double check the work. There are 2 silvers on the reactant side and 2 silvers on the product side, 2 nitrates on the reactant side and 2 nitrates on the product side, 1 calcium on the reactant side and 1 calcium on the product side, 2 chlorides on the reactant side and 2 chlorides on the product side. This equation is now balanced. Here's one for you to try. Balance this equation, which shows hydrogen peroxide decomposing to form water and oxygen gas. When you're ready, press pause, try to balance the equation, and then press play and check your answer. Hopefully your balanced equation looks like this. 2 moles of hydrogen peroxide decomposing to form 2 moles of water and 1 mole of oxygen. Here's how it was done. The first thing you may have noticed was that there were 3 oxygens total on the product side. 2 from the oxygen and 1 from the water. Since there were only 2 oxygens to begin with on the reactant side and the 1 hydrogen peroxide, we needed more oxygen on the reactant side. So by placing a 2 in front of the hydrogen peroxide, and since you multiply any coefficient by the subscripts in the formula, that gives you 4 oxygens on the reactant side. The 2 also distributes to the 2 subscript for the hydrogen. So we have 4 hydrogens as well on the reactant side. For the hydrogen on the product side, put a 2 in front of water, and that 2 gets multiplied by the subscript 2 for the hydrogen in the water, so that will give us 4 hydrogen. The 2 oxygen from the 2 water molecules added to the 2 oxygen atoms from the 1 oxygen molecule add up to be 4 oxygen total. So you now have 4 hydrogen on the reactant side and 4 hydrogen on the product side. You also have 4 oxygen on the reactant side, and then 2 plus 2 is the 4 oxygen on the product side. Remember, double checking to make sure that you have the same number of each element present on both sides of the equation is a very important step. And this equation is balanced. If you got it right, good work. That's a closer look at balancing equations. If you'd like more Chemistry Matters, go to our homepage where the entire series is available to you.